Most one-year test sites, and so my understanding of the ethos of that program was to take people that didn't know as much about Sage as some of the developers and some of the coders and so forth, and to have them use it in the classroom. And so I certainly fell into that category as of last year when I showed up to Sage Days, and so to learn about Sage and then to incorporate it into my abstract algebra class for this year. So just give you a little bit of background about the institution that I come from. Whitman College, we're a small liberal arts school in Walla Walla, Washington, about 45 minutes from here by plane, 4 hours by car. We have about 1,500 students. Our department teaches about 400 students per semester, mostly service courses, lots of calculus, lots of students doing linear algebra, differential equations, and so forth. We graduate about 10 math majors per year, though this has spiked in the last few years, and the numbers in the course kind of bore this out in terms of what it was that we were able to the number of students taking the course. And so for the course that I taught, the abstract algebra course, it's a year-long sequence. We offer it every other year in rotation with our math analysis course. Our math majors are required to take, among other courses, 2 of the Algebra 1-2 and Analysis 1-2, so 2 of those 4 courses. We really strongly encourage our stronger students especially to take at least 3 or even all 4 of these courses, and so some of our better students do that in preparation for graduate school. Students come into algebra they've had 3 semesters of calculus already, a proofs course, and either usually a differential equations or a linear algebra course. And then this is the description from the catalog of the course that we teach. It's a pretty standard abstract algebra course. First semester is all about groups, rings, some fields, subgroups, quotient groups, homomorphisms, isomorphisms, etc. And then topics for the second semester are pretty much up to the professor, and I'll talk more specifically about what we did during the second semester in the course. Prerequisite, the only prerequisite is that proofs course, but that has as its prerequisite, of course, the calculus sequence that students have to pass. And so for my abstract algebra course, we had 26 students in the course, which is about twice as many as we normally enroll in the course. And so when I've taught it in the past, it was running at about 12. We had 10 seniors, 15 juniors, 1 brave sophomore who was probably the best student in the class, and then all but 2 of them were math majors. We had one brave physics major and 1 chemistry major that decided they wanted to take abstract algebra. And then from the spring class, we held over 19 of those students from the original 26. A few went on study abroad, but most students took that. When I've taught this course in the past, it's usually 5 to 7 students, and so this is sort of a paradigm shift for me in terms of the number of students enrolled in the course. In the fall semester, we worked through Judson's online algebra textbook, and so we were able to pick and choose the chapters that were relevant to the topics that we were looking at. We worked through approximately 1 chapter per week. Student responsibilities were kind of heavy for this course, and that was sort of borne out in the feedback that I got from students. And so student responsibilities, 7 to 9 written homework exercises per week, 1 Sage assignment per chapter, biweekly quizzes with both in-class and take-home portions, and then a midterm with an oral component, comprehensive final. The oral component was it was a 10-minute oral exam. They had to come in and state the 3 isomorphism theorems. They'd pick 1 at random, they'd prove it, and they really appreciated that, sort of being able to talk back in terms of the mathematics. We actually give our seniors take oral comprehensive exams before they leave Whitman, and so this is kind of a good foreshadowing of that. The class met twice a week for 80 minutes, which wasn't the best in terms of timing. That class got a little bit long for those 2 times per week, and so spreading out a little bit more might have gone a little bit better. Let me show you specifically what the Sage assignments look like, and so let me bring up the layout of the book here. So what Judson's book has is each chapter is laid out into a Sage notebook worksheet, and so the students are able to download these as a zip file and then have these on hand throughout the course of the semester. And so they also have a PDF version of the book that they can work from, and so if they don't want to bust out Sage every time they want to look up something in the book, they've got this available to them. And so they've got the PDF available to them. But the way this is laid out is this is pretty much verbatim what's in the textbook. And so it goes through all the different figures and everything's laid out here nicely for us. And then after the homework exercises within the chapter, all right, so there's a section on Sage for each chapter, and the Sage was written by Rob Beezer, who's not in the room at the moment, but that's okay. And what it does is it gives sort of a preamble of what Sage can do for the chapter. So this is, I picked out about rings. This talks about how you create rings in Sage, so a little bit of help for students as far as that goes. And then some actual practice that you can run through some of the cells and take a look at what Sage can do for you. And then walk you through some exercises, answering some questions, and then this is what the Sage assignment would look like. And the student can actually download just the assignment portion as a separate worksheet. And so they'll just turn in, they won't turn in the full chapter, but they'll turn in just the 4 exercises that are, here are the 6 exercises per chapter or whatever. And so the exercises are some basic verify things. And then in this chapter in particular, what they're doing is they're creating some finite fields and looking at some ideals and some principally generated ideals. And so they're coming to their conjectures about, Z is a principal ideal domain. And for finite fields, right, finite fields have a cyclic multiplicative group. And so they're able to actually use Sage to generate the data and say, oh, this looks like this is going on. And so make the conjectures based on that. And then I can use that in the next class period to say, so what did Sage tell you about, about finite fields? What did Sage tell you about the different ideals that you generated and so forth? So that's what's going on as far as that goes. Come back here and talk. Right. And then in the second semester, in terms of what we did for the topics, we did Galois theory before spring break, and then we did finite groups and simple groups and group structures after spring break. We also spent a week on symmetry and art with a field trip. So we talked about different symmetry groups and then took a field trip to downtown Walla Walla, and students took pictures of different symmetries they found in different places. And then they had a week of student project presentations. And so one of the complaints from the fall semester was that I see there's this chapter on cryptography, I see there's this chapter on coding theory, but we didn't have time to get to it in the fall semester. And so students were able to then choose that as a project topic for the semester. And so they worked in groups of 3 and gave half-hour talks and wrote exam questions for each other about their different project presentations. So that's what we did for the spring. The atmosphere in the class was really highly collaborative, and I had a really good group of students that kind of fed into this. And so I really encouraged collaboration on both the homework, turning in the Sage assignments in pairs. After the first couple chapters, was looking at 26 different Sage worksheets. That seemed to be a little bit much, and so I wanted them to be able to collaborate on the Sage assignments and to work on those. And so class time was largely interactive lecture format, but they had ample opportunity for students to explore. So when we got to, this is the symmetry group on the square, I actually had them construct squares and flip them around and so forth and write down what they did. Exploring roots of unity, creation of frieze patterns during the art unit and so forth. So yeah, so that was how the class time was spent. And so the utmost project, I think, my understanding of it was that it was twofold for using both open source text materials and using Sage in the classroom. And so I tried to incorporate both of those. And reaction to the text was generally very, very favorable. So we've got a tradition at Whitman of using open source throughout our calculus sequence. And so David Gashard, I know many of you are familiar with his calculus book, and so most of the students see that in the calculus sequence at some point. And then our Intro to Proofs course also has an open source book that we use and add and remove chapters from among ourselves. And so we haven't actually put that one out of Whitman yet, but that might be one avenue that we could explore. So. And they're kind of beyond the stage of, well, it's free, so I'm happy about that. They're actually able to critique the book, and for this book they thought it nicely complemented the place of the class. I really appreciated that it was modular enough in nature that I could pick the different chapters and the different topics from the chapters that I could use, and then to do projects for the second semester. As far as Sage goes, the reaction to Sage was we used it primarily in the fall, and the reactions were kind of mixed to negative among the students in terms of what they got out of Sage. The frustration that students felt were kind of inversely proportional to past programming experience. So I had a couple, people with a lot of programming experience. My favorite student comment was, well, come on, it's Python. You can put your face down on the keyboard and it will do exactly what you want it to. Whereas other students kind of felt a little bit hamstrung with the worksheets in that they didn't really have a global sense of what was going on. They could work through the commands and they could do exactly what the worksheet told them to do. But when they tried to off-road a little bit, that's where it got frustrating. And so, and complaining about the sort of voluminousness of the help files. And so that there's a lot of things in the help files that they don't really necessarily need to know about or need to see about, and trying to find exactly what it is that they need help with was a little bit frustrating for them. Some of the better students were able to blend LaTeX and Sage really nicely without very many issues as far as that goes. at least a couple students, even some of the better ones that didn't really feel like programming much, just wrote off the 5% of the grade that was about Sage. And so I know that a lot of people I've talked to have had Sage optional in their courses. I decided not to go that route, but maybe that would be one route to go in the future as far as using Sage. So,
quick question.
Yeah.
So you say common complaints, lack of help documentation, but then what you said was
Right.
there's too much help.
Okay, so by lack, I think maybe lack of useful help documentation for them in terms of finding what it is that they want to do. So in the second semester, it wasn't used. We didn't use it as explicitly in the classroom, but students still found, some of the better students still found it useful for finding roots of polynomials, looking at structures of larger groups, and so forth. One of the seniors used it in her senior project. She was looking at Pythagorean triples and which Pythagorean triples have angle trisectability. And so without any kind of prompting from me, she just said, oh, she turned in a Sage worksheet one time as part of her senior project. And so this is what I did to motivate some conjectures and so forth. So it was useful for the students that made use of it, but those that complained about it didn't really get that much out of it, I don't think. So in terms of improving the experience, I mean, I would like to run this again, and I would like to run this in different courses. And so what I could be doing as far as improving the experience is to give students some more of that global acumen in terms of what's going on. And I'm not a Python programmer, and so what I could do is kind of slow down the first couple chapters of the Judson book, which do give more background in terms of Sage. For our students, the way the first couple chapters work is that they are rehashing a lot of what they've seen in their proofs course. And so the students tend to kind of breeze through those couple chapters in terms of the exercises and so forth. And so what I could do there is not focus so much on the material, but maybe slow down, do some more Sage, bringing in some more Sage into the classroom each day. And the course probably should meet for a full 4 hours each week. I mean, we're meeting effectively 3 hours a week, or a little bit less than 3 hours a week in the fall. If we met the full 4 hours a week, we could devote at least half of one day to Sage and actually being up there in the classroom. So, I mean, I brought it in on occasion, but it wasn't a regularly built-in part of the course, and so that really should be part of how it should be in there. And then, as far as integrating Sage further into our curriculum, I mean, I liked a lot of what I heard about the SFA model, where you've got Sage in the calculus course, and then it builds up throughout the course of your time as a student there. And so we're moving to a more webwork-based calculus in the calculus sequence, and so I'm interested to hear what Sage can do as far as webwork goes, and getting students to be thinking in those terms before they get to the level of the abstract algebra course. We also run a calculus laboratory course that we require of all of our students, and in years past that has been twofold. It's been using computing software to solve longer problems, but also learning mathematical typesetting and mathematical writing and how to actually write up a mathematical report. And so with Sage, with LaTeX so nicely blended into Sage and using Sage Tech, we could probably replace Maple with Sage, keep the LaTeX portion of it, and do the same things that we're doing currently in the course, but incorporating Sage. And then we could also use it for other upper level courses. So this week we've been working on combinatorics and graph theory, and I would like to see something similar in terms of chapter by chapter worksheets, Sage exercises for our combinatorics course. We also offer upper level courses, mathematical modeling and operations research come to mind as courses that could incorporate Sage fairly easily. So that's it as far as my experience goes.
Questions?
So when I used Sage in abstract algebra, partly because I wasn't sure what I was doing, it was worth about 5% of their grade the first time.
Yeah.
10%, and then I went up to about 20%.
Okay.
And I didn't get those people just totally skipping it.
Right.
I mean, I did get some sort of fall off. They wouldn't do the harder questions at the end of a set.
Okay.
But at 5%, I had the same experience. There were people who just said, it's too much work. I'm not spending my time on it. So I think if you up it, if you're comfortable with that, you might get better participation.
Yeah. Also, the iterative approach among different classes.
Right.
Greg alluded to that. You build on something that somebody else did. It's not you being idiosyncratic requiring this.
Right.
You might know abstract algebra, but simple algebra 5% ain't that much.
Yes.
Hey, quick question for you is actually maybe for William too. You had mentioned that you kind of make two versions, one with the solutions and one
There's
with
two
problems.
worksheets?
Two
Well,
worksheets.
one has just the SAGE exercises, and one
Oh,
has
I'm
the whole
sorry,
chapter
yeah.
on the SAGE
I
exercises.
guess that's what I've been doing, is
Yeah.
having a solutions version.
Okay.
Is there interest in the educational use of having sort of a secret cell or a password protected version embedded within a version that once the work has been submitted, they could have the solutions just revealed,
Okay.
and then
Yeah. I think you need that because if you start, you need that sort of thing because in worksheets where part of it is encrypted or stored server side only but can still be executed, and the reason is because when you write problems, very often if the student could look at the code to generate the problem, that would also tell them the solution. Yeah, and also if you want to give hints, if you want to check the answer, if that code's in a worksheet, then you must make parts of the worksheet not available to the viewer.
right. So that's going
Yeah.
to be in the
Yeah, it's
design.
absolutely necessary to have any hope of writing problems, I think.
Great, thank you.
But I don't know the exact, I mean, there's a couple of ways to approach it. But I think one is to have the code get stored not in the worksheet, but it'll be linked to something that's in a database elsewhere via UUID or something like that.
Okay. I was actually just kind of,
But
while I was listening,
Encryption
thinking,
can
oh,
work
could
too.
it be an interact, where they'd have to enter
Yeah.
in a password or something
Well,
to
yeah,
reveal
it'd be
that.
easy for us to make permalinks so that they didn't just put this code in the cell, but the permalink would fetch the code and
Fetch the code.
execute it and just give
Yeah.
you the result.
That's a good idea, yeah.
We already have the.
well, it depends whether you want to have, like, I don't know, depends where, there's a lot of options,
Yeah,
but,
there's a lot of options, but that's one option.
and there's
Instead
a
of
whole
fetching-
workflow to worry about of like
There's-
making the problems and editing them.
It would be an advantage if the author can kind of put everything in one
Would-
place,
exactly,
the problem
yeah.
and then the solution and so
Yeah.
on, and also in distribution, that would be helpful.
So actually encryption could be useful, actually, because you could just have like part of the worksheets encrypted, as you're saying, and the author will have the key to decrypt it, so when they're looking at the worksheet, they can see the decrypted version
Right.
in like a red box,
I was just
and
thinking like a
the
little
student
percent.
can't. And
Percent encryption.
Yeah.
Yeah.
Yeah, but then you still need to somehow decrypt it when the student's executing it, right?
Yes.
Somewhere there needs
Yeah,
to be a
yeah.
key storage, yeah.
Yeah.
yep.
Oh, I'm just kind of curious, so you say you didn't assign the save silence in the second step?
I was using a different text for the
Oh,
first
okay.
part, and then when we got back to Judson for the last couple,
Oh, okay.
chapters, there were the
That
SAGE
makes
assignments
sense.
done, so, yeah, yeah.
So can you think of any way we could improve the book? And I'm especially concerned about thinking about format, because if I were to do it again, knowing what I know now, I might strongly consider XML. I might strongly consider using the single cell server somehow.
Yeah.
Can you think of any other things,
The
other
XML might
other
be
than
away
fixing
from-
some of
yeah.
the errors that are still left?
The XML might get away from some of Jason's first 8 steps before the last 2 steps in terms of executing what you need to for the textbook, and so that might be a little bit nicer. They really appreciated having both the sort of regular PDF version and the online version of the books as well to use, and so having that as a book, I think that's useful for them. So, and on the final, actually in my final second semester, I gave that open book, and we had to sort of get students into airplane mode with their laptops, so they could download the PDF exactly and have the PDF exactly, but no other online resources. So, all right, thanks.
Thank you.